As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientics, INSIS, Vocation, Creatis, MarTech, Electics, Plan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes.
Distinguished guests, ladies and gentlemen, before we start commence the program, and here are the following webinar protocol. For each participant ID, please use your real name following with your origin of institution. All of participants are expected to mute the audio and only unmute the video during the event. We cordially invite you to take your own firm and comfort seat in your own room, and please avoid the backlight. Make sure that you have a good and stable internet connection. If you have an earphone or headset, we recommend you to use it so that your voice can clearly and loudly to be heard. During the Q&A discussion session, all participants, please use the chat box to deliver the questions. Thank you for your cooperation and consideration.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to guest lecture series on SDGs today, Wednesday, 30 June 2021. I am Vivi Rianggeni from ITS Global Engagement and will be your Masters of Ceremony this afternoon. Thank you for joining our guest lecture series on SDGs today. Before we start our agenda, let me inform you some rules for this event. First, please adjust your name or ID screen using format name_your_campus. Second, during the lecture, please turn off your microphone and only turn on the microphone when the moderator gives the chance. Third, please fill your attendance at bit.ly/attendance/GLS SDGs, or our committee also send the attendance links through the Zoom chat room. For the participant who wish to get a certificate and stamp, please fill the attendance 15 minutes after the session starts. Fourth, participant who wish to ask question during question and answer session, please send your question to intip.in/Q&A/GLS-SDGs. The link for the question listed on the chat room as well. Or you can ask directly by clicking the raise hand feature. Today's session, we are going to listen a lecturer from Professor Yusri Yusof from University Tun Hussein on Malaysia. And today's topic is retrofitted machine with IR 4.0 for Sustainable Development Project. Today's session will be moderated by Ibu Nur Hidayatul Alami from ITS. Before we start our agenda, allow me to deliver our schedule today as follows. First, opening. Second, introduction to moderator and speaker. Third, lecture session. Fourth, Q&A session. Fifth, certificate awarding. Sixth, closing. Now, before we proceed to the next agenda, let me introduce our moderator today. Our moderator today is Ibu Nur Hidayatul Alami from Institut Teknologi 10 November. Ibu Nur Hidayati also has the bachelor degree in biology at Universitas Airlangga and got master degree in biology at Universitas Airlangga. And her professional experience right now, Ibu Nur Hidayatu as the lecturer at Biology Department at ITS. Bu Nur Hidayat also has a research project experience from May until November 2021, prototype research 2022, ability of marine yachts to degrade plastic polymers floating in the marine environment, funded by Local Fund 2020 Institute Teknologi 10 November. The next research project experience, Ibu Nur also has the department research. The title is The Potential Yes, Screening for Atrazine Degradation, funded by Local Fund 2019 Institute Teknologi 10 November. And Budaya also has the publication in 2020. The title, The Potential of the Youth Isolated from Agricultural Soil in Atrazine Degradation. And in 2019, the title is Extracellular Alkaline Phosphate from Mangrove Soil. Yes. Now, without further ado, let's proceed to the agenda to Ibu Nur Hidayat. The time is yours.
Okay, thank you so much, Mbak Vivi and the committee of guest lecture series. Assalamualaikum warahmatullahi wabarakatuh. And good afternoon, ladies and gentlemen. So once again, I would like to say welcome to this program of guest lecture series on sustainable development goals today. And I'm Nur Hidayatul Alami from the Biology Department of ITS. It's my pleasure to be here as a moderator in these sessions with the topic of retrofitted machine with industrial revolution of IR 4.0 for sustainable development projects. And ladies and gentlemen, I'm sure that this topic is very interesting, as this is, as we know that one of the many of the challenges today is one of them is how to achieve the sustainable development goals, and the other is how to adapt the innovation which define the industrial revolution of 4.0, and both challenges require innovative thinking. So I think we cannot wait to just start this talk today. But firstly, maybe Mbak Vivi, I'm briefly introduce to you about our speaker today, Professor Yusri Yusof from the University Tun Hussein on Malaysia, sorry, UTHM. So this is the education background of Professor Yusri. From 2004 until 2007, Prof. Yusri graduate with a doctorate degree or PhD degree at Loughborough University, UK. And also before that, Prof. Yusri graduate with a bachelor degree at University Teknologi Malaysia. And also Prof. Yusri continued to the master degree at University Teknologi Malaysia. And there also a professional experience of Prof. Yusri from 2015 to present. He was professor at Faculty of Mechanical and Manufacturing Engineering, University Tun Hussein on Malaysia. And from May 2011 to 2015, he was associate professor of Faculty of Mechanical and Manufacturing Engineering, University Tun Hussein on Malaysia. And from 2008 to 2011, he was a senior lecturer at the Faculty of Mechanical and Manufacturing Engineering, University Tun Hussein on Malaysia. So this is the curriculum vitae of the Professor Yusri Yusof. And nice to meet you, Prof. Yusri.
Nice to meet you too. Thanks for my introduction. Introduce myself.
Okay, you're welcome, Prof. So, based on the schedule today, Prof, Prof Yusri will give a talk about an hour, and after that, it will continue to the question and answer sessions around 30 minutes. Okay, so welcome to Prof Yusri, and please, time is yours, Prof.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And selamat sore, Ibu Moderator, Committee from ITS, the pimpinan ITS, Pak Rektor, dan Pak Dekan, my colleague from Malaysia, my close friend from Malaysia and Indonesia, maybe from others as well. So first and all, thank you very much. Thanks for the invitation, especially for the committee. My great pleasure today to share something with you. I hope I can contribute something in terms of knowledge sharing. And at the same time, I also welcome any question, any idea for collaboration, strengthen our research activity. And this participant also, I got my student as well, my PhD student. I can see some faces there. So first of all, Alhamdulillah, again. So my topic today is talking about the IR 4.0. So we believe, where? Need to check again the material. Okay, good. Okay, everyone can see my slide. Sorry, it's not.
Yes, Prof.
Oh, sorry. Oh, one moment. I want to change the slide. This is the old one.
Sorry, Professor, you are still on mute.
No, where to? This one. Let me check again. Sorry.
No problem, Prof. Just take it easy.
Okay. I think the first slide is to some mistake there. So by the way, apologize for the take some time to find out the proper material. So first of all, thank you very much again for the ITS for the invitation. So this is the poster you have shared. Okay, a little bit about my university. You can hear me, right? Boleh dengar ya?
Yes, Prof.
Yes, sir.
Okay, good. Okay,
Yes,
little
Prof.
bit about my university. So I'm from University Tun Hussein on Malaysia, located southern part of the Peninsula Malaysia, so close to Singapore. So our is UTM, University Technology Malaysia. So our focus is more to the technical courses. You can see that we aim to produce more professional practice. So we offer a lot of engineering technologies and also engineering technologies program. So we have three branches. So we have in the main campus in the Parit Raja Batu Pahat, also in Johor. And also we have the second branch in the Tanjung Labuh. So the three faculty in Tanjung Labuh focus for the technology engineering, science, and diploma program. The rest is in the main campus. And we also have in Tanjung Labuh, where on focus for the aeronautic program. So we have the piloting program, we have the aircraft maintenance, and air traffic control. Overall, we have combination of engineering, technologies, and TVET. We call that TVET program. We have the management program as well, aeronautic. Consider new program is railway and also BTEC. So we have a combination of engineering, technology engineering, management, BTEC program, and specialized. So we have aeronautic. You can see our student full cover by the pilot dress. So about myself, I've been involved in the higher learning institution for more than 20 years. Now it's 21 years in education itself. Before this, also involved in Polytechnic. We call that time is Polytechnic Johor Bahru. And also be a supervisor for the PhD candidate, panel for the as an external examiner for the supervisor for PhD thesis, and got some invitation from abroad and also from local institution in Indonesia as well. And this is a little bit about my scopus of publication. Consider I'm in the average levels. I'm sure some of you more than me in terms of number, citation, publication, and this and that. And the grant is in Ringgit Malaysia. You call that close to 2 million, so around 500 USD, 500K USD, and also involved actively in the conference committee recently and also the coming year as well. This is my scopus print screen. Just this year, last year, I have been got invitation as the visiting professor from the Madinah University in Saudi Arabia for 1 semester. So teaching master's management courses, and same time also to strengthen the accreditation under IBAC from Madinah University. So this is my honor. About my career, so far have been involved in the holy place as Madinah as a Muslim. So this also takes opportunity for me as well to perform Umrah as well. So Alhamdulillah. So a little bit about our research group in Batu Pahat, Johor. We have a postgrad student. Before this also we got the postgrad student. So Dr. Aini from UTM have been involved 1 year's attachment in our lab to strengthen the research activity. And we plan, and also what we have done is to upgrade our washing machine, our old CNC machine. not washing machine, our CNC machine. In terms of controller, in terms of the capability of the machine. So what we do, this under the technique machine scope, you call in Bahasa Indonesia, technique machine or manufacturing. We utilize the old machine. So the old machine is not working machine, the failure machine, disposed machine. So we try to make sure that machine well running, and we equip with the latest technology. So the scenario is we have the old car, not working car. We change certain part of the car component. We upgrade the system. So finally we have old car, but now it's latest technology, maybe with the GLS system. So this is the scenario there. So finally, we call the authority bodies in Malaysia to validate our machine, our system. So we don't feel that we upgrade, we change, we modify. So finally, we verify ourselves. So that's why we call the third party, in our case, is a Syrian body to check and validate our system. So this is roughly about the activity in our research lab. So at the moment, we have numbers of machine. You can see that listed in the slide. We have the milling machine. Milling is something, we have the tool, we have the part. So we rotate the cutting tool. So the raw material is static. So this is the simple concept of the milling. And then we also have turning. So when the other area around, so we have the tool, we have the part. So part is moving, part is rotating. So the cutting tool just to touch and also hit the material, and finally machine. So the machine is, we call that, we remove unwanted material. I'm sure in this room we have some from the technique machine background and others as well. So I try my best to narrow down the tone of the explanation. Hopefully everyone can follow and can understand my explanation. The rest is we equip with the system. We call that IoT system for the monitoring, for the inspection, and also the whole system as well. So this is we apply for the 3-axis machine. So in the slide, we can see that before this, the name, so this is the machine. So you can see the Danford Novel machine. We also have the ProLight CNC machine. We also have the turning machine. Then we equip with the system, we call that. So the machine itself, only the machine. So we support with the system. So system can communicate and also can monitor, finally can generate to the report. So as a user, as a customer, they can go to the system, they can log in, and then our dream is to utilize our smartphone. So our phone now, our smartphone not only communicate with others person between Malaysia and Indonesia, for example, but we try to utilize to communicate to the machine as well. I want to see after this as well. So this is, we call that disposed machine. So where our machine is more than 15 years, close to 20 years. You can see the motherboard, so the PC, all type of PC. You can see the blue and dark color there. So this is very difficult to find it now, this type of the PC. So the machine is used from the different faculty. So after almost 10 years, we make a decision that machine is not working. So we dispose this machine. So we claim that is the zero value machine because we have the lifespan. So this is more than that. So our group is take opportunity. So we discuss among our group members, with students. So the idea is, that's why we call that in terms of sustainability. So this machine should be divorced. So we try to utilize the old machine, not working machine. We try to change maybe certain part of the machine, the failure part, the not running well, for example. Then the same time we improve the system. So this is the spec of the machine. We consider this a small machine, only 3 axis machine. Only the size also a small machine. So we have also big machine, bigger than that, but very difficult to convince ourselves first, to convince others. We have the capability. So that's why we start with the small thing. So the moral is, when we do research, so normally we start with the small scale. We start with the, nobody know what you have done, for example. But finally, we hope that we can contribute something, not only to our institution, to our university, but also to our country as well. So what we do is, you can see the first photo and the second one. The main component is there. We not much we change the component. What we try to do is we change the software part. The hardware, whatever working, we remain that particular machine. We change the software part. So the idea is, before this, if you use this machine, they are only allowed certain level of the we call that the controller. So the good example is, you have the laptop, you have the printer. So if you buy this kind of laptop, you only allowed to print only this type of printer. This is the original idea. If you buy this laptop A, you only allowed to print in this B type of printer. So our idea is, you can buy any laptop, you can choose any printer, because this is called that universal, and we try to make it open system. Its closed system is controlled by the manufacturer. So they gives you the condition. If you buy this one, you should buy the package. If you buy this laptop, you should also buy this printer. Got the idea? So if you change this printer, you need to change all the laptop or all the controller as well. So we feel that very difficult when we move to Industry 4.0. We're talking about the more flexibility. We're talking about control by others, for example. So we should thinking about, as a user, as a customer, we can plan ourselves, because our requirement is different. Our need also different. So people can advise, manufacturer can advise, manufacturer can propose, but as a user, we know what is our need, what is our requirement, because maybe our need is totally different from their needs. So this is the idea. So that's why we change the controller, make it open, so you can use whatever system, whatever CAN system. So this is the idea. Before this, for example, you use, some of you from the technician also familiar. If you use, for example, Mazak machine, so the system is Mazatrol. So Mazatrol is compatible with the Mazak machine. If you use different controller, so they not communicate. Certain part, they not communicate well, for example. This is the idea. So what we do is, we know that the machine have the combination of the hardware. We call that the body itself. They have the controller, the brain of the machine. So look like we have the printer, they have the we call that the controller. Otherwise, how to send whatever material to the printer. So the printer is another part, so the machine is another part. So we call that this is the controller. Then we have the hardware, where we have all the component, the tools, the cutting tool, the bed, for example, the chart, for example, all the hardware. And then we have the software. So software is where you control the machine. So like your printer as well, you also you need to install, to communicate, to send, to monitor, for example, to give some idea how I want to change. You want to print it 1 page or 2 page, for example. So this is, we call that the controller. So this is our machine. We have another thing is totally different is our ISO, to make sure that the current ISO is ISO 6983. This we call that GM code. Is you familiar with the CNC machine? You can't run away from the GM code. GM code is the language, the language we use to communicate with the machine and also from the CAD. So when the CAD, you design something, then you want to pass to the machine, they must have the communication tool able to communicate well. So ISO 16983 is we consider as an old standard. So now they come up is another ISO, we call that ISO 14649. ISO 14649 is, the idea is to make it open system. So before this, the philosophy before is you ask what you want to machine. For example, I have this kind of mouse. So the machine don't know to machine is mouse. The machine is no idea. But you insert the machine is go this line certain distance. Go this way certain distance. Go that way certain distance. Do insert to the machine. But another new ISO 14649, they're more intelligent. That means you give the instruction is I want to machine the pocket. So the next question is they ask you about the dimension of the pocket because they know already to machine is pocket. Pocket that means one whole square certain deep. So we call that one is pocket. So when they know that one is pocket, that means they have the feature, they have the idea. The to machine is pocket, so they know already this is a 3D dimension. Maybe ask how about the width, how about the deep, how about the length, for example. This is the next question. So this is the difference between old ISO and also new ISO. It's too detailed, please allow me, notice me to make it faster. Or too fast, please give some note, make sure that slow down. So we have the standard. Okay, next one is talking about the system. Before this, we improve in terms of the hardware. That means the not working machine now is working. The next question is we want to upgrade the level of the system. So the analogy is the old type of car. Now we want to make it keyless car. So keyless is considered the latest one. So we have the hardware. Then we have the desktop where we want to change whatever requirement. Then we have the mobile where we have the smartphone. We want to control by smartphone. Before this only desktop. Now we want to use smartphone. And finally, to make sure that all the three components, hardware, the software, and also the mobile, the controller, working well. Otherwise, there may be two of them communicate, and the third one is not communicate very well, to make sure that running smooth. So the idea is we have the system. One is to monitor, one is to have the camera to make sure that where you want to machine, where you want to convert from the old system to another system. So this is the graphic to show that how they move from one phase to another phase. After we make sure that none very well, so then the final phase is to make sure that we have another smartphone to communicate to the controller, to the machine. This is the bottom one is the software. The left side is the controller. The mobile is another device to communicate. Before this, we don't have this kind of device. You just imagine, is that particular machine is more than 20 years. So that particular time, we don't have this kind of technology. Okay, now we have the smartphone. We have the controller. We use Wi-Fi. How to communicate? We don't want to use a wired communication. From the smartphone to the machine. So we want to use Wi-Fi. Then we have send for the registered our IP. We call that OU UOCC, Open CNC Controller, as our product, as our name, our brand. So we call that UOCC. We have file for the IP under registered. Then the first phase is, of course, involve the hardware. It means whatever we want to use, whatever we want to change. So make sure that, for example, first we want to change the server, we change to the stepper motor, we change the another controller. So this is the detail on in terms of the graphic, in terms of the schematic diagram. Sorry, too technical, but you can imagine when we want to change engine of the car. So not only engine, but also all the wiring, all the controller, all the another part also involved. Not only change the engine, because engine also have the others part also communicate or control to the engine. Engine itself is another thing, but how the support tool, how the communication tool as well, we need to change necessary if we think that that one is related. And then you can see the old type of monitor. If you want to sell this type of monitor, so nobody want to use because we have moved from the Nokia to Samsung. So that's why we have the touch screen and others as well. So finally, we upgrade. You can see from left to right, certain part, whatever part we think that we can remain, we can remain. Whatever part we think that we can improve as well. So finally, we got the smartphone. So now we have the desktop, where we have the system we want to install in the desktop. They are involved in the 3D interpreter. We have the main menu. We call that one is GUI, Graphic User Interface, where the user need to key in something, need to instruct something. So this is the main purpose of our desktop. So this is the print screen, one of the example. We need to change the number. We want to change the data there. So this is where, for example, certain process we can remain, certain process we change. For example, before this, maybe we use tooling machine tool number 1. The second process maybe involve tooling number 2. So the requirement is different, the size is different. So this is where we control the system. Okay, the next one is involved in the, we call that monitoring. Monitoring is to make sure that before this, we didn't have this kind of system in our machine. So now when we have the monitoring, so we can put where is the minimum number, where is the minimum and maximum. For example, the example there is a temperature. What happened is you run the machine, the temperature is too high. So that means the effect not only the part, also involve the the productivity, involve the efficiency of the machine, or maybe they will destroy machine at the end, for example. So this is the issue, because when you machine the hard material, so the temperature is high, and also the precision, the friction is so high. A lot of things involved. Either we use a coolant, this is just to reduce, but the temperature is high. So the idea is we have set the temperature, what is the minimum, where is the maximum, where is in the comfort. So you can see that we have the safe condition where you allow this kind of range. Next one is we have the warning. They're close to the border. When we have the warning, for example, as myself, for example, my target is what number of kilogram, my weight, for example. It's certain number, so I start trigger myself. I need to take care of my diet. I need to take care of my exercise, for example. So this is, we call that warning. Then we have the danger, where we need to make a decision to stop the machine. Otherwise, they'll be broken. Otherwise, will be destroyed. Otherwise, there will be effect to more danger, for example. So this is the philosophy of the monitoring. Same goes to the vibration, because we know that this kind of machine not only involve the temperature, but also involve the rotating vibration. That means when you rotate something, there must be the vibration is there. So that's why we need to control the vibration. So same as well, we had the zone where very safe. Then we had the warning, and also the red zone, we call that. There we need to make a decision to stop the machine. This is the final part. We call that mobile. After the machine is run well, we have the part where we want to use our smartphone to communicate. So the idea is we want to adapt with the latest technology. Where somewhere some people say that can you machine utilize IoT, for example, in Internet of Things? Before we don't have anything, so that's why we try to adapt some technology under IR 4.0. So this is the desktop. We want to duplicate whatever appear in desktop to your mobile phone. So that means we have the machine, we have the desktop, the controller, then we have the smartphone. I think now everyone has a smartphone. So to make sure that whatever appear in the machine, we can appear to the smartphone as well. Allow me to have some water as well. Excuse me.
Yes, Prof.
Okay, to make sure that then communicate whatever in the system to the smartphone. Okay, this is, you see that the biggest one is the original one. Then we have the smartphone, where the smartphone is mirror or duplicate whatever appear in the system. So this look like work well. So a lot of things involved. You can see that this research not only involved in the technique machine, also involved in technique electric, and also involved in the computer science or IT as well. So because we do the cross discipline. So now a lot of things talking about the multitasking, cross discipline. So you can see that my idea maybe I can solve something about the technique machine or manufacturing. But how about the programming? How about the sensor? How about the IoT? How about the smartphone, for example? So that's why a lot of party involved. So hope I can play this video, short video. You can see. Oh, sorry. Work well, right?
machining process monitoring challenges that we are facing today. Are you looking to reduce the machining operator workload? Reduce complexity for faster response? Integrating CNC machine tool with emerging technology? Looking for a solution? Don't worry, we got the solution. Towards Cyber Physical Machine Tool. Modern Monitoring Milling Process, 3MP. 3MP is an IoT-based monitoring system developed under STEP NC environment. 3MP system is a network of CNC machine, central computer and mobile device. It is an integrated solution that securely connected CNC machine and other mobile device using single IP address. It provides integrated communication solution that enables CNC machine to be monitored without operator present near the machine. MP capture machining information such as cutting tool temperature, spindle current and vibration of cutting tool and workpiece interaction in real time via Wi-Fi module. It is a powerful system that helps to detect unseen machining critical event even through office. MP enable to give alarm during movement anytime anywhere in virtually manner. MP reduce workload by sharing the same information in real-time through any mobile device, reduce complexity by advanced human-machine interface and monitoring visualization, enable to control machining information by monitoring and machining integration. Great, thank you, my pleasure. 3MP system validation. 3MP system implementation on Perlite CNC milling machine. Machining setting. Machining process. Web-based monitoring. Alarm system. Control action by machining parameter control. Report generation. Sound interesting? Contact for details.
Okay, the next one is you can see that particular video involved my PhD student. Three of them. One is considered completed. Another one is waiting for Viva. And the next one is at the end of the process of the thesis writing. But the next one is only my final year project. This is our final year project, undergraduate. Before this is a postgraduate. So this is project come up with the model, communicate also through the smartphone. But at the end, they notice to our WhatsApp, our SMS. But this case is we notice whatever notification come to our email. So this is undergraduate. We use the smartphone. We can read the data. We can generate the data, and we can control as well. And whatever notification we can send to the third party as a user, as the owner, as the manager, that particular company or factory, for example. Okay, notification. This case is goes to the email. So this is you can set whatever. So it's another thing. Monitoring is another thing, but reporting is another thing. Otherwise, so you have the issue. How to control, but to make sure that come to the appropriate person in charge. They need to make sure that take immediate action. So last round of the presentation, you can see that we change from the old machine, not working machine to the working machine. Then we can upgrade, and also we improve in terms of the standard. Of course, at the end, we hope that we contribute in terms of the safety as well. We can have also a real-time expansion. This is very important. We don't want to know the final product, then we claim that that one is reject. So make sure before the final rejection, during the process, we can predict and also make a decision as well. Involved in the data mining, of course, this is involved in data mining. We have to span to the cloud as well. So at the end is cloud is another component to store our data. So another contribution is come to last part. So actually we are patent. This is our IP in terms of our remote control. So we file this kind of the for our IP. Then the next one is our publication. So this is based on that particular research. So we managed to got this number of publication under the Q1 journal. So from the review part, from the framework, and also from the real research. So this is 2019, and from 2021, 2020, you can see that this review part. We have another monitoring, we call that. This is another publication under International Journal of Advanced Manufacturing Technology. That one is 2020, all the 3 Q1 paper. This is another under Springer Professional. We come up with a case study. This is 2021. You can see that 2021, we also managed to have 4, I think. Yes, 4 paper from that particular project. And still waiting another 2 under consideration. We got the first round is a major revision by middle of this month, hopefully, or next month. We hope we can respond back to the editor. This is our potential collaborator. We got some number of requests from our collaborator. Okay, this is our in the mission lab where we have visited by our Deputy Vice Chancellor. So this is the person in charge in the research activity in our university. And also before that, also we got our Vice Chancellor, Pak Rector, and also our Chairman, Board of Director to our lab. And this is, we call that the final one is a serum assessment where our authority body in Malaysia, we call that serum, where they control all the ISO, all the standard is under this particular authority. So under the mission center, so this is under mission center, they come to check our mission. And finally, they give this report to verify, we call that the verification of the retrofitted 3-axis milling machine. So by the mission center section under Missionary Technology Center, Sirim Berhad. They give long report, so not only to verify, also we claim that easy for us to otherwise, so you do the report, the project, you publish the paper, you apply for the grant. So this document is very important for us to make sure that we is hopefully easy to get another fund, another collaborator, because they are justify our work. And they claim that this is because this is not the yesterday project. We started the project is since 2013. And what is the scope of verification? So to see the readiness of our researcher in terms of the industry 0, and also for the mission itself. That's why we call that retrofitted pro-light 3-axis machine. So this is the conclusion. So you just imagine we have under IR 4.0 a lot of pillar. So they claim that we apply IR, we apply integration, we apply cloud, IoT, data security, simulation, so on and so on. So this is the most component under IR 4.0 verified by this body. And another thing is give the idea how we can upgrade our lab from the level of laboratory to center of excellence. So this is report from the authority body. So we hope that we can more collaboration from institution, others, hopefully from ITS as well, from our partner from Indonesia and Malaysia and others as well. We can use this we call that proof of concept, because certain requirement for our big fund, they're looking for the proof of concept. So that verification we can use as a proof of concept. We can hope that we can have more PhD students to crash their brain, to explore the opportunity to this kind of research in our lab. And we also feel that this is a part of collaboration. So this sharing session also, we feel that this is a part of recognition as well. So I take last slide of my presentation. This opportunity, we got another invitation for a special issue under Taylor franchise journal. So under IETE Research Journal of Research. So the due date is 25th October this year. For those who are interested, please contact me for this kind of purpose. So with that, thank you very much. I hand over to the moderator.
Okay, thank you so much, Prof. Yusri, for really interesting talk, as my background is quite far from this machine, but I try to understand it. And yeah, I have noted some important things here that, so the basic idea here is, if we talk about IR 4.0, it's thing that we think about flexibility. So this is the basic idea of this.
Yes.
This system, right? So this is like a cyber system that implement in many areas. And Prof. Yusri also have explained about the principle and description about this machine. And also one thing that I note here is smartphone can communicate to the machine. That's really awesome. Okay, and then also Prof. Yusri have explained about the development of the system, starting from the phase 1 until phase 4, in the last phase, starting from the hardware development until we build the system validations. And there's so many questions. I'm sure that there's so many questions related to this topic. Maybe is anyone have a questions? You can raise your hand, and also you can text the question to the chat room, and also by give your questions using form response. Okay, is there any questions? I have already see in the chat room here, but there's still no raised hand here. But this is the first question here from Aya. So I will read it. Good evening. My name is Aya from Egypt. Is it possible to send the scientific material through the email or any other method? Thank you.
Scientific material, right?
Yes, the scientific material. Is it possible to send the scientific material through the email or any other method?
The question is to send the material, scientific material.
Yes, Prof. The scientific material. Scientific material.
Of course.
What is?
I don't know exactly what the purpose or the behind of the particular question, but
yes.
The general question to send the scientific material through email should be no issue at all. So I will respond is no issue, no problem. You can send scientific material through email or whatever, to WhatsApp, through attachment. But what is the purpose for the scientific material? To send to the journal, to send to the editor?
Yes.
is not respond properly to the question, hope that person can contact me, email me. Hopefully, I will answer.
Yes.
Thank you.
Okay, maybe Aya will communicate with Prof. Yusri later,
Yes,
maybe to give the the detailed explanation about this scientific material. Okay, and the next questions is from GH. How do you start to integrate between computer and machine program in the hardware system? And what is the problem that you face in the beginning stage?
Okay, thank you. Very good question. Because I can see the beauty, the good, the successful is there. But the not mentioned is the hard work, the tough work, the bad work, for example, the behind this kind of the successful is a lot of things involved. So first, what we do is we start with the small thing first. I always mention to my student and my group. So whatever we want to do, start with the small thing first. Just to convince yourself you're able to do something. We start with small thing. You want to talking about the big machine, we start with the small machine. We want to have the 4 module, we start with the 1 module. You want to start with the complicated programming, we start with the simple one. I give one example. I think if you are learn about the programming, so we start to program the simple programming like calculator, for example, and we know the answer. We know we start to program how to write a calculator, programming calculator. So we know the answer. We put the number. So for example, 2 times 2. Make sure the answer is 4. We know the answer is 4. Why we use that one? Because they want to make sure that simple, everyone know, work well. So after the calculator is working well, you put the number 2 times 2, the answer is 4. Then you check the programming, also the answer is 4. Then you're happy. I'm happy, I'm sure this is calculator work well. Then after that, for example, you vote, you key in whatever number. Then you trust the system. You trust the programming. So the idea is we start something simple, make sure that working well. After that, you can grow it up. You can make it more complicated. What is the challenging? The challenge part is we involve in the programming, we involve in the sensor, we involve in the small component, the sensor, the tiny part. So very difficult. In the big part should be no problem because that one you can see working or not. But the electronic, the device, the sensor, now you can see that the modern tool now, the part become smaller and smaller. So this is the sensitivity is there. When you test in the lab, working well, but you go to the real field, they have the problem. So this is the challenge because to make sure that you test in the lab working well, not necessary in the field also working well because a lot of things involved. A lot of things is so affected by the the sensor not working, for example, the environment, the condition may be different, which the control by in your lab. So consider one of the biggest challenge as well in our project. Thank you.
Okay, I think it's clear enough about the explanations. And yeah, this is another questions, Professor. Is it possible to email? Is it possible to email from Aya? Is it possible to email Professor Yusri or any other method of communication?
Oh, okay. Okay, communication. So, thank you for the question and also further explanation about the first question. So,
yes.
in case, if we refer to our case is communication, that means when we have something wrong in the machine, how to notify to the user, how to notify to the customer, for example. So what we do is we use one of the example is email. Another example, maybe we can use SMS, for example, but now people have migrated from SMS to WhatsApp, for example. So this is, the idea is to make sure that the system is working well. So that's why we use email, because email also trigger to your smartphone. Email also you can read anywhere, for example. So this is why email. Another thing is email is considered official communication tool. So when you read the email, you can print screen, you can use as evidence. In the court as well, you can use, that's why the official evidence. So this is why of the reason we use email as a communication, easy to access to the user, to the system, and to notify to the end user as well. Is it? I hope I answer the question.
Okay, thank you, Prof. Yusri. So this is the answer of the questions. We hope that is clear enough about the questions. Is anyone have a question again? Maybe by raise your hand, and then maybe I will check for the form response here. There still no questions here.
I think in the chat room.
In the chat room. Okay. Assalamualaikum, Prof. and fellow researchers. My name is Fatur Rahman from Mechanical Engineering Department, Polimas Kedah, Malaysia. My question is, what is the timing range for the machine to respond the signal input from the device used in order to ensure its validation? Thank you. The timing range.
Okay, the timing range for the machine to respond the signal. Okay, this is very technical question.
Yes.
I think the best way is better communicate with me later. I can't respond immediate because it is very technical. I can mention whatever number, but maybe wrong. So I need to check with my student, my PhD student. So thanks for the question. So I really hope you can email or communicate with me later for the specific answer. So in general, of course, we have the range. The question is to make sure that one is validated. We don't want to put, long time to trigger the user. It's happened now, for example, maybe after 1 hour, then you notify to the user. So too late. So must be respond as soon as possible. So our idea is real time. So I can explain this. Our idea is real time. Whatever happen, automatically they will notice you. You ask how many seconds, I need to check a specific data. But our idea is real-time data. Emergency button, okay. To very critical for the emergency button. Of course, emergency button, that one is immediately. That's why when we have the red color zone, so when they come to the Z color zone, automatically we off the machine. Automatically with the trigger the machine is off, because that one we can set and we can change the range. For example, now we set, for example, 2 seconds, we can put another 3 seconds. Now we put this number of temperature, we can change. The one is user can yourself based on your requirement. Of course, for the emergency response, that one is immediately, otherwise no emergency at all. Thank you.
Okay, thank you, Prof. So Mr. Fatur Rahman have response to the explanation, Prof. Thank you, Prof. It's very crucial for emergency button response during process. And this is other questions here, Prof. What is the problem that your research team face about real-time monitoring system with the advanced electronic device such as mobile phone when the machine has occurred the accident or fault?
Okay, the real challenge is how to make sure that real time. So sometimes we call that real time, but there may be delay microsecond, for example. because whatever you talk, for example, they have the range, the time to transfer. For example, we try our best to make sure that real time, not only real time, but also come to real time. This is the biggest challenge. But of course, we have some limitation as well in terms of the component, in terms of device, for example, because this one also involve the electronic, the sensor itself, for example, they also take time. When you heat something, the sensor for temperature, so temperature also have time to take the real data to display whatever real data has appeared. So this is also come from the sensor or from the device. So from device also need to communicate to the controller. But at the end, we think that we take not longer time. This is the best way to explain. Otherwise, for the critical one, for example, is anything emergency, we try our best to get the, I put the terminology is real time. Thank you very much.
Okay, thank you so much, Professor. So the questions is coming from Inji Chuan Huat from the University Tun Hussein on Malaysia.
Yeah, okay.
So
okay,
this is Prof. Yusri students, I think.
Okay.
Oh, colleague. Okay, I'm sorry. Okay, is there any question? So Prof, has this system been applied in some of the area? I mean, industry or something like public services?
Okay, good question. So at the moment, we got a number of inquiry to visit our system, our machine. But in Malaysia now is under MCO till don't know yet. So that's why we still hold all the actually myself also not allowed going to the university. So because this COVID, so we conduct our class online. So before this, also I have also class. So I need to have the special permission going to university. Before this, compulsory for all the staff goes to university. But now work from home. So only for those that they claim that it's critical sector. For example, for security, for example, they're allowed. So involve the financial, they're allowed. Otherwise, let's say at the moment, not allowed. So thank you.
Okay, thank you, Professor. And this is also the second question from Mr. Fatur Rahman. Yeah. Okay, here I will read the questions. My second question, Prof. Since the communication use is wireless, is there any possible of the loss of Wi-Fi connection, and does it back up with Bluetooth or GSM for connection backup?
Okay, thank you very much. This also question come from the Polytechnic.
Yes.
We call that Polytechnic, Alostar, Polytechnic Jitra. So at the moment we use Wi-Fi, but you can change Bluetooth, whatever platform. Another thing is we call that we have the contact and also non-contact device. The question is how about to read the temperature. So we have the contact device, so where the sensor need to touch the component contacted. Or we also have the non-contact from far away. We have the device, for example, camera. So they can use that particular camera, can notice, can got the data, for example. So whatever device. So the point is, we not bother about device. As long device can generate the data, we are more than happy. So either contacted or non-contacted. So to answer is at the moment to utilize contacted or non-contacted sensor for temperature. Thank you.
Okay, thank you, Prof, for the explanations. And this is other questions. Assalamualaikum, Prof. Yusri. I'm Syed Fadli from Mechanical Engineering Department, Polimas Kedah. My questions is about the temperature monitoring system. What temperature did the system collect? The tool temperature or the workpiece temperature? Thank you, Prof.
Okay, that's why at the moment we consider the workpiece, but we change for the tool as well. So that's why if that particular system able to read the data from the contact or non-contact device for the temperature, so as long come from the workpiece or come from the tool, because at the end we need to consider both. Temperature also come generate from the workpiece. Temperature also generated by the tool. So at the moment we can say that we consider both from the tool and also from the device. Contacted or non-contacted.
Okay, Prof. Thank you for the explanations. So all of the participants have responded the explanation of the questions in the chat room also. And yeah, thank you for the answer, Prof. Okay. Maybe Prof. Yusri, would you give the explanation again to me, especially in which aspect, Prof, this retrofitted machine with IR 4.0 are one of the tools that appropriate for the implementing SDGs?
Okay.
Yeah.
First, I can say that at the moment, the old machine is not working. We just want to write off the machine. So I believe in Indonesia, in Malaysia, a lot of machines come from the training provider, such as polytechnic, college, universities. So whatever cost related to the technique machine, I'm sure they are got this kind of machine. Whatever number of exits, whatever brand, but they have the CNC machine. So CNC machine is considered the expensive machine. You need to spend 500K, for example, in ringgit Malaysia to buy a new one. Depend on the complexity, depend on the capability of the machine. And they maybe cost you up to 1 million, for example, depend on the. So the idea is all the machine, what we can do at the moment is zero value. We can't do anything. So at least we can do some modification, not only modification, but at least we adapt with the latest technology. You just imagine the old machine, maybe the age is 20 years old or 15 years old. That time, no IoT, no wireless, for example. But we change little bit of component, we can adapt with the latest technology. So at least our current student, they can utilize the institution as well. Then don't need to spend a lot of money. At least we can use this old machine, adapt with the latest technology. That is the idea. So that's why we call that the sustainability project. Sustainability project is we reuse the old machine, adapt with the latest technology.
Okay, thank you so much, Prof. That really clear for me about this implementation of this this machine for the SDGs. Okay, maybe there's still another questions here. No. I think Professor Yusri have already explained about and answer all of the questions in the sessions. So how about the committee? Is the time up? That was really interesting topic.
Yeah. Actually, still more time, Ibu. But if
Yes.
in occasion is up to Ibu Hidayah.
Okay. So, how about the impact, Prof. Yusri? Is there any impact for the, for the sustainable development aspect? Is there any, the long-term impact for in the future?
Okay, thank you. The question about the sustainable development for the long-term future, future direction, for example. So this kind of research can convince or prove that the first we're talking about the open system. So we try to no manipulation anymore. don't control. I mean, if you remember, I use the analogy, you use this kind of laptop or printer, this kind of PC, you only allowed to print this kind of printer. So this is the system we call the open system. Up to you which printer you want to use, which system you want to use. So you can, we're talking about open, that means up to you, based on the user, based on your requirement, based on your need, for example. So this is one thing. The second thing is, before this, we only as a user. So whatever come from the developed country, we only as a user. All the controller, all the machine, we only as a user. So at least we can open our mind. So one day, perhaps we can use as a creator to create something, to develop something. So I think this is most important thing. So especially for young generation, to convince yourself, you're able by your hard working, survived by the supervisor, read a lot of things. So finally, you need to try again. So finally, you manage to do whatever you dream. Thank you.
Thank you so much, Prof. Yusri, for really clear explanations. Okay, so all of the questions have, all the questions have explained by Professor Yusri. Thank you so much, Prof.
My pleasure.
Finally, I think this is the end of this session of question and answer questions. And thank you so much once again for Prof. Yusri Yusof from the University Tun Hussein on Malaysia, and for the time and for the valuable knowledge that sharing with us. And also, ladies and gentlemen, thank you so much for your active participations in this guest lecture series. And I hope that we all enjoy this session. And thank you so much. And I will back the session to the MC. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh. And good afternoon.
Thank you so much to Professor Yusri and Ibu Nur as our moderator today. Please give applause for our speaker and moderator by using the Zoom reaction feature. Furthermore, we would like to present a certificate awarding to our speaker and also our moderator today. In addition, we are very sorry that it's not signed yet by our rector since we are in the lockdown. This is certificate presented to Professor Yusri Yusof.
Oh, thank you.
Thank you so much. And next, this is a certificate presented itu for Ibu Nurul Hidayatul. Bu Nur Hidayatul.
Thank you.
Now, before we end our lecture today, we invite you all the participants as well as honorable speaker and moderator to take a group photo. To all the participants, please turn on your camera if possible. Okay, as we have two slides here, please wait a minute for the first slide. Okay, I'm going to count 1, 2, 3, and smile. Okay, the next slide. 1, 2, 3, and smile. Now we have finished the group photo. And for the participant, please don't forget to fill the feedback link that I will provide on the chat box. For the participant, fill the feedback from the true link bit.ly/feedback GLS that you can also see on the Zoom chat room. The deadline for filling the feedback is from 1 hour After we finish this session, we want to remind you the participant will get the stamp or the participant who come on time and fill the feedback form. Finally, we have reached the end of today's guest lecture series, and we sincerely apologize for any mistake we may have made in presenting as Master of Ceremony and Committee. Thank you very much to our honorable speaker and moderator and all the participants for the attention and cooperation.
Thank you very much. Thank you.
Thank you so much, Prof. Yusri and committee and all participants.
Thank you so much, Professor Yusri and Ibu Nur, and also Pak Irfansyah.
Thank you, Professor Yusri. Hopefully, after the pandemic, maybe we can visit each other.
Yes,
UTHM.
sure.
So ITS
Yes,
and UTHM, I believe similar, yeah. Technology university.
Yeah. Technology.
Focusing much on technology, and you should visit us in our labs. We have CNC as well, and that we develop in the.
Sure. We try my best. So hope we can meet as soon as possible after.
Yeah, inshallah. Okay. Thank you very much, and also thank you, Bu Nur Hidayatul. Thank you.